notations for P and Q. Now, this must come first because this is dz dx, this is dz dy. This must come first. It must be written in that standard formula. The standard formula is, it must look like this: something dz dx plus something dz dy is equal to something without any derivative. So this one should come first. So minus xp plus yq is equal to z. This is minus x dz over dx plus y dz over dy is equal to z. This is the same as this. So now this is the standard form. This is the standard form now. So we write dash equals dash equals dash. Whatever that is here, we turn it upside down. But this one we turn to ordinary. We turn this one upside down. This one comes up here as ordinary dx. This one comes down here as this. We turn this one upside down, ordinary dy. This one comes here as this. This one doesn't have any derivative. So the derivative is the common one here. So the z is here and z is down. So there are three things here. You choose two of them and solve. Two solvable ones and solve. So we can choose the x over minus x is equal to dy over y. We can choose the x over minus x is equal to dy over y. This one is not impossible, it's possible to solve. So we solve it by integrating both sides. This is minus ln x is equal to ln y plus c, the constant. So I have grouping like terms. Minus ln x minus ln y is equal to c. Minus out ln x plus ln y is equal to c. Minus ln xy is equal to c. So I have ln xy is equal to minus c. Xy is equal to e to the power minus c. This is a constant, so I can have xy is equal to c1. So you see that a function is equal to a constant one. So for the first one, I need to find another, I need to choose another one. I've solved this to get, this is just an ordinary differential equation. This is just an ordinary differential equation. So let's pick the second one. Any other one, I pick this and this. I can pick the next one, this and this. So the second one I can pick because it is solvable. That means, if I say because it is solvable, that means there is a possibility that sometimes you can choose a pair that is not solvable. So this one too, we can integrate directly. So we have integral dy over y, integral dz over z. This is the same as ln of x minus ln of y. Ln of x equals ln of z plus c2 as my constant. Well, from the last equation, we have ln of y is equal to ln of z plus c2. I want to simplify this. We make sure that always we put all the variables on one side and the constant on the other side. So we have ln of y minus ln z is equal to 2. This can be represented by a smaller constant. So y over z is equal to, let's say, c3. Now, comparing these two answers, the other one we had xy is equal to c1, a constant one, non-zero constant. This is y over z is equal to another non-zero constant. So therefore, per the rule that we learned, we have f of, the first one is xy, comma, the second one is y over z is equal to 0. This is the solution. This is the solution. Even though we have integrated to get this, we try to put all the variables on one side and leave the constants on the right hand side. Make sure we get our answer in the simplest form before we apply whatever